This is over how to graph ratio table. Is this table correctly written? If I spend $2, I will get 6 tickets. If I spend $5, I'll get 15 tickets. If I spend $7, I will get 40 tickets. What if I just spend $1? Because I don't want that many tickets. If I spend $1, I will get 3 tickets. If I spend $3, 3, 6, I will get 9 tickets. If I spend $4, I will get 12 tickets. So, from what I can tell here, I'm multiplying the cost by $3 to get 3 tickets. I'm multiplying the cost of $2 by 3 to get 6 tickets. I multiply the $5 by 3 to get 15 tickets. If I multiply $7 by 3, this should be 21 tickets. So the latter part of the table is completely wrong. So you know Halloween is coming. So Mark received 6 pounds of candy from 3 dozen homes. At this rate, how many pounds of candy did he receive from 2 dozen homes? Create a table. Let's create a table. Do. So this is about pounds, and these are dozens of homes. So if I 6 pounds of candy, you get from 3 dozen homes. I would like to know how many pounds of candy can I get from 2 dozen homes. Well, looking at what we know about ratio tables, we can do it between these, or between or within. No, I'm gonna do it within. How do you turn 3 dozen home to 6 pounds? You multiply by 2. So if I multiply it by 2, this could be 4 pounds. Or I can use unit rate. If I simplify this, divide both numbers by 3, 2 pounds for every dozen home. So build up the table, scale up. 2 dozen home, 4 pounds of candy. 3 dozen homes, 6 pounds of candy. So here's my table. I could have done it as I did unit rate, as you can see, and then I increased the table. I scaled up. Did you know you can graph this? Today we're going to be learning how to graph it. So you can solve it through graph. 1 dozen home is 2 pounds of candy. 2 dozen home, 4 pounds of candy. 3 dozen home, 6 pounds of candy. 4 dozen home, 8 pounds of candy. 5 dozen home, 10 pounds of candy. So by the end of this lesson, you will be able to graph from a table and find different particular points. So the Webster family lives 120 miles from Washington, D.C. They take the express train when traveling to D.C., which travels at a constant speed and makes the trip in 2 hours. The table shows the given rate from the scenario. Complete the table using the given rate. So let's see. In 2 hours, they can go 120 miles. Let's break it down to a unit rate. In 1 hour, they can do 60 miles. In 3 hours, see, every hour they can do 60 miles. So 2 hours, 120, to 3, 60, 60, 60, that would be 180. What if they do it for 4 hours? That'd be 60, 60, 60, 60, or 240. Can I just multiply by 60? Yes, I can. So let's look at here. What is, so half of an hour would be 30 miles, because half an hour is 5/10. Half of 60 miles is 30. So if I add the 3 hours to half an hour, or 180 to 30, that would be 210 miles. Or you can find the median, the in-between number of 180 and 240. So let's see, 5 and 5/10 hour. Ooh. So if it's 5 hours, again, every hour is 60, that would be 300. So 5.5 hours be a half an hour is 30. That would be 330. So what is the relationship between time and distance? Where is my, oh, here it is. There is, the relationship is there is 60 miles for every hour. That's the relationship I see. What is the unit rate for this scenario? The unit rate is 60 miles per every hour, or for each hour. Are the rates a representative table equivalent? Let's see, 1 is 60, 2 is, if you simplify 2 and 120, it will become 160. So the answer must be yes. How would you use the table to find the time it takes to travel 420 miles? So if I have to find 420 miles, I can keep on building up. So 6 times 60 is 360. 7 times 60 is 420. So it'd be 7 hours. Or what about me dividing by 60 to figure that out? So graph the values from the table. So let's graph the values and use the time for the x-axis of the distance. So 1 hour is 60. 1 hour is 60. 2 hours 120. 3 hours 180. 0 hour is 0 miles. 4 hours is 240. 5 hours is 300. Does it make sense to connect it? Yes. Why would we connect it? Well, the reason why you would connect it is there aren't a train. Does a train stop every minute? No. It doesn't go from 0 hour all the way straight into 1 hour. It didn't go from 0 miles to 60 miles and just like that. It has to constantly move to reach that point. Mandy says that in 2.5 hours, the express train travel 100 days. So 2.5 hours, 150. Because we know every half hour is 30 miles. So yes, I say she is correct. Jake says the express train can travel 300 miles in 5 hours. Yes, is he correct? Look at the table. How would you use the graph to find the distance traveled in 6 hours? You continue with the table. So you can do 6 right here. And you know this will be 330. So the next one will be 360. Another way you can see it is, you know, for every hour you can move 60 miles. So every hour is 60 miles. So it's 5 hours, it's 300. And if you tack on another hour, you add another 60 miles. And is the relationship additive or multiplicative? It's multiplicative because for every hour, you're going 60. For every 2 hours, you're going 120. To do that, you multiply by 60. Look at our table. We multiply by 60 to reach that point. So 5 boxes of candy contains 60 candles. So 5 boxes of candle contains 60 candles. Each box holds the same number of candles. Complete the table. I can do it between or within. How do I turn 60 to 5? How do I turn 60 candles to 5? I can divide by 12. Or how do I turn 5 boxes to 60? I can multiply by 12. So if I multiply the box by 12, I get 12 candles. If I multiply the 2 boxes by 12, I get 24 candles. If I multiply the 8 by 12, I get 96. Let's do the opposite. To turn the candles to the boxes, you have to divide by 12. So if I divide this by 12, then that would be 10 boxes. What is the relationship between the number of boxes and number of candles? For what I can tell, there are 12 candles for each box, or there are 12 candles per box. So what is the unit rate? The unit rate are 12 candles per box. How would you use this table to find the number of candles that will be in 12 boxes? Well, if I had to find for 12 boxes, I can tack this onto the boxes part of that row. I know I need to multiply by 12, so it'd be 144. So graph it. Use the boxes for the x-axis and candles for the y-axis. So let's see, one box was 12 candles, two boxes was 24, three was 36, four was 48, five was 60, six was 72, and so on. Does it make sense to connect the points on the graph? Why or why not? I would say no. If you connect it, you can't have like 2.001 boxes, because you cannot have like 24 point something candle. That doesn't make sense. It's either a candle or not. So no. How would you use the graph to determine the number of boxes needed for 36 candle? With 36 is here, it will be 3 boxes. Does the order pair 7.5? Right here. 7.5. Okay, so 8 would be 96. 7.5 will be right here. Does it make sense? Well, let's see. I know each box holds 12 candles. So 7 boxes will have, 12 more, it will be 84. Half of a box would be 6. So I will say yes, it does make sense. You can buy half of a box, but you cannot buy like half a candle or a quarter of a candle. Is this relationship additive or multiplicative? It is multiplicative. So what we learned in this lesson is, from a real life scenario, can you create a table from it? From that table, can you graph the information? And through this graph, you're able to answer many, many different types of questions.